Okay, welcome. Today we're going to finish up looking at application problems involving logarithmic equations and exponential equations. This is video number 2. This involves logarithmic equations. All right, make sure your notes out, and I'm going to go ahead and begin. Astronomy. The apparent magnitude of a star is a measure of the brightness of the star as it appears to observers on Earth. The apparent magnitude m of the dimmest star that can be seen with a telescope is given by the function m is equal to 5 times the log of d plus 2, where d is the diameter in millimeters of the telescope's objective lenses. If a telescope can reveal stars with a magnitude of 12, what is the diameter of its objective lens? Okay, first thing we want to do is ask ourselves, what is this problem asking us to find? So I'm going to go ahead and highlight that right now. It's asking us what is the diameter of the objective lens of a telescope. And to find this, they tell us that it reveals that the star has a magnitude of 12, and it also gives us a function. And when we're given a function, we have to identify what each variable means. We have m and d, so let's go ahead and write those down. Write your function down, and we'll identify what m is equal to and d is equal to. All right, as we read, it says the apparent magnitude m. So m is our apparent magnitude of the dimmest star. So I'm going to go ahead and write that. It's the magnitude of the dimmest star. We also have d. And it says d is the diameter in millimeters of the telescope's objective lens. So let's go ahead and write that down. And let's make sure we realize this is in millimeters. Okay, so to answer our question, what is the diameter of the objective lens? Well, that's d, so it looks like we're going to look for d. And it gives us the magnitude, or the telescope reveals the star's magnitude is 12. So this is what we know. This is a simple identify what our variables equal, plug them into the equation, and solve the equation. So let's go ahead and write our formula up here. M is equal to 5 times log of d plus 2 with a simple substitution. We know m is 12, so I'm going to go ahead and substitute that in. We know I'm looking for d. We're going to leave that alone, and now we get to solve for d. Now I see this is a logarithmic equation, so I'm going to have to isolate the log. So I'm going to subtract 2 because they add 2 and they multiply by 5, so I'll divide by 5. So with a quick subtraction, and a quick division, I can see that 2 is equal to the log of d. Now, I can't use equality because this is log base 10. This is our common log. I don't have a log on this side, so I have to jump to exponentiating. So I'm going to exponentiate both sides by the base of our common log, which just happens to be 10. So I'll write our base here. So this becomes 10 to the log d power is equal to 10 squared. I know 10 squared is 100. I know because these are inverses of each other, that will isolate my d. So in this case, d is equal to 100. So the diameter of our objective lens is going to be, and we'll go ahead and take the question mark out, and go ahead and write in our answer, 100 millimeters. Okay, that answers our question. What's the diameter of objective lens? It's 100 millimeters. We used it by simply identifying our variables, substituting them in, and then using techniques to solve logarithmic equations, which in this case was exponentiating. So if you have any questions, go ahead and write them down on the side, and we'll handle them during class.